And while I am awake, I also had very 2 hours of sleep only yesterday. Okay, so all of you are data structure experts, and of course, you know what is cyclic graphs and spanning trees. So let me just quick overview of that. You know about vertices and edges or nodes. Okay, node and vertices as well as edges. So how many wedges are there? Okay, nodes are there. I am not going to wait for your answer, so you guys know it. Now, are there any loops? I think yes. And spanning trees are formed. Okay, what are the spanning trees? They are formed by removing all the loops in the graph. Okay, we should not have any loops. That means what, we have to remove some links. Remove in the sense, we are not going to physically remove them. We are going to make them inactive. That means the node, these are all what are they? Okay, they are all bridges. Okay, bridge. As I said, bridges are not only two port. Okay, this bridge is having only two ports. It is listening on two LANs or two segments. Okay, it's not two different LANs. It's same LAN. Please remember, they are all belong to the same LAN, but they are listening to two different LAN segments. Okay, like what you saw in segment LAN 1, LAN 2. Whereas this is also, we are going to call it as a bridge. It is connected to three different LAN segments. So going forward, we are not going to restrict bridges to be only two port devices. Even switches which are on multiple LAN segments, okay, are going to be called as bridges for our algorithm. Okay, so what is a spanning tree? They are removing all the loops in the graph by retaining all the vertices. Okay, we are not going to knock off all the vertices and removing some of the edges such that all the loops are removed from the graph. All the vertices are still connected to each other. Okay, that you have to make sure that still all the vertices are connected. So we don't want there is isolation of these two links. We cannot disconnect, because then any host connected to this particular segment all will be disconnected from the rest of the world. Okay, so effectively you have to understand that this is a one logical LAN with multiple physical LAN segments connected through either bridges or switches with multiple ports, and then we are trying to make sure that all of them are still connected. At the same time, there are no loops, because I told you that earlier, whatever we saw, loops are going to cause trouble, because the algorithm what is running on the individual bridges are same, right? They are going to take from one port and then see whether it has come from the same port, and if it assume that the destination MAC address of that particular frame lies on the other side of the port, it will send it. Okay, now the loops are formed and then there is a circular movement of frames, because the bridges which are there in the particular network, they were not talking to each other. They don't know the existence of the other, and they thought they are the only device in the network, and they are supposed to do the job what it is supposed, no, what is programmed to. So if you do not add the additional intelligence that you are not only going to be connecting to different segment, there may be somebody else connecting it, or to some other bridges or some switches, there may be a loop again. You can come around. Okay, the frames can go all the way again, come back to the same LAN segment. Okay, so there are possibility that the packet whatever one host is sending on a particular LAN may go around, even though it has been received by somebody and they have responded to the packet. This one which is lying there will be going around. So don't think the way IP packets are handled, TTL, why can't we handle that way inside the LAN? No, it's not possible. We'll not go into the details of why it's not possible and why can't we just do a time to live in Ethernet frame level also. Maybe you can look for some paper or some publishing. But what I'm saying is, here is going to be a traffic is going to be more, because LAN segments are running at a gigabits of a second, and then when it is going from one port to the other port, or sorry, one network to other network, the traffic is not going to be so much, and we cannot bring in the TTL idea here. So we are trying to find out how do we avoid loops so that the frames are delivered are routed inside the LAN segment from A to B without going into loops and then forming a hogging the network. Now what is the issue of these packets going around? Please remember, the bandwidth of particular LAN is limited. Okay, it's designed for some gigabits per second. Now if you keep sending the same packet on the network, it's not, you are not going to send during that time, you are not going to send another frame in the time. So you are wasting the bandwidth of the segment, right? LAN segment. So it's a wastage of energy, wastage of time, and efficiency. So we have to have a solution for this. Okay, that's what I'm trying to arrive at. Now spanning tree can be many. Given a particular tree, I can show you multiple spanning trees can be realized. Now which one would you build? Again, it depends on the algorithm which is running on the network. Okay, so one more thing is, when these LAN segments are getting formed, different segments are getting connected. Now Sachin will suddenly come in our RVU, and then you will think that okay, one more new batch of students have come and we have to add a new switch, and then he'll come and connect it, and then make all the hosts connected to that switch. Now what happens if LAN is expanding like this? It will land into trouble, like forming a loop somewhere. Okay, we may not know which is causing the problem, which switch you added last is causing the problem, but there's going to be an issue. Okay, now I don't know. Okay, somebody is asking question. Some of them are still waiting. Okay, oh sorry. uh, Admit all. In this time, no, don't wait for message. Okay, you just talk. I hope I have not muted all of you. I am saying admit all. Oh, sorry, I did not notice that. Okay, in case if that is the problem, please let me know so that I will let you in immediately. So let me summarize. Now I think people who have come in late, which I did not allow them. So let me summarize. Now, why do we need a spanning tree or this kind of a setup? Inside a LAN, there are many paths could be realized from one segment to another LAN segment. Now inside this particular picture, we are not showing the host at all. Please don't think that A, B, C are the host. No, they are the bridges which of interest for us and connecting different LAN segments. So hosts are not showed in this graph. Okay, they are there causing some traffic inside the LAN, but they are not shown. But we are not interested in knowing how many hosts are there. Anyway, we expect it to be there. Now the aim of this particular algorithm is to make sure that there are no loops formed, so that the frames which are going from one source to the other destination reaches in a possibly in a one single path within the, though there are multiple paths available, we will try to disable some of the links or do not send any traffic over them. We will not disconnect them. We will not send the traffic over them. So the bridges will still be listening, but it will not do any action on it, or it will not forward anything on that particular port. So that way, some bridges will keep quiet, but they will be allowed. They will be around. They will be alive and then doing the monitoring the thing happening. And they may kick in sometime when one particular link is failing or one bridge is conked off. Anything happens to one of the devices, then other device wakes up. Okay, that possibility is also there. Okay, that's why redundancy is brought in. At the same time, it is not causing the looping problem, and at the time of requirement, it will be uh, taking, coming up an action and then take over the control, okay, of the LAN. Okay, now let me come out of it. Let us go to the main crux of the discussion today is this particular session. Okay, okay, anybody else waiting again? Yeah, let me take them, bring them in. Not only in the class, even during the online meeting, people coming late are going to cause some disturbance to the class. Okay, okay, let me start. Thank you. So let us start. Now recap on. I will quickly cover this. Okay, you can actually go through it offline also. Okay, what happens when there are loops? Now someone asked me, I think Smaran, that when B is replying, why can't we understand that okay, B is on this side, A is on this side, or why can't the loops be removed? No, there's a looping of things will. Okay, nobody is waiting. Okay, sorry. Okay, now I'll tell you that scenario I have given in this slide. Let me say where it is coming. Now imagine that the situation, oh my god. Okay, imagine a situation wherein the entries are different. Okay, one bridge assumes that host A is on port 1, and other bridge is assuming that host A is on the port 2 of it. Okay, port 1, port 1 on the same side, okay, of both the bridges. Now what happens is this issue will be a problem. Okay, um, okay, we'll recording is there, so we'll have here. Otherwise, come down to new block somewhere and catch some, find a place and then please join. Um, I am continuing. Okay, so now let me explain this. Okay, bridge 2. Okay, where am I? Okay, bridge 2 is receiving the frame on LAN 2. Okay, whatever it got, it sent it here and it is receiving. Now it understands the source address is A on this side and then it sends it on the other one. Now imagine then now bridge 2 will now send the frame again on LAN 1. Okay, that's I think we have seen this. Okay, now what happened when the B replies? Okay, when B replies, let me explain you that also will get into a trouble. Okay, when B replies, it is going to say that my source address is host B and my destination is host A, and it is going to come here B to A. Now there is no entry for B here. Okay, remember we now only first this fellow is responding, right? Then both of them will see the B on this side. Now imagine this bridge 1 is little ahead of bridge 2, okay, or the other way around. Okay, let us I don't know what I am assuming here. Okay, what happens to the entries of forwarding table? Now what will happen is B is sending to A, right? Now what will bridge 1 do? Think of this. Bridge 1 knows that A is on port 1 side. Okay, and B is sending. Okay, it may learn that B is also on 1. Okay, new information, new word. Now A is 1. Okay, now the packet is saying that B is sending to A, and bridge 1 sees that it is on port 1 side only. Okay, and receives the B to A packet also on this side. Now as far as bridge 1 is concerned, it will know that okay, A is on this side only, I know, and the A will take care of responding back or receiving it. I don't need to forward it to other side of the thing. So bridge 1 will keep quiet. Okay, bridge 1 will not take any action because it knows that A and B are on the same side. Okay, because it sees that B is sending from this side, and it says I want to talk to A, and it knows that A is on port 1 side, so I don't have to take any action. It will not send it here. Whereas poor guy, this bridge 2 is still in the imaginary world that A is on this side of the port. So it will pass on that B to A packet here. Now what happens? This bridge 1 we are confusing the bridge 1 because of this guy sending the reply on this side of the LAN. Now bridge 1 thinks just now it thought that B is on this side and it made an entry. Now it sees that source B address is coming here. Remember one more thing, bridges do not change the contents of the frame. Similarly, routers do not change the contents of the IP packets. They only read it, understand it, forward it. They know maybe TTL value will decrement it in the router case, whereas here maybe it will compute that CRC. That also need not be done because it is not changing any content of the packet. So CRC value also will be same. So it will just pass on. Okay, it doesn't do much of any work. So now bridge 1 will see that source B is coming from this side. Then it will assume that B is on 2, LAN 2. So now what will happen? There is again mismatch of the entry of B also happening. So B will start rotating. No, the B to A reply will start going in the reverse direction. Okay, that so could be a possible scenario of even with the reply, it is not going to be able to find any good solution. Okay, so the only solution that you can think of is to make them learn, and one of them keeping quiet. Okay, one of them keeping quiet and not forwarding is the only solution. That means if they have to be quiet, then they need to talk to each other. Okay, otherwise they will not know the existence of each other. Now how do you make them talk to each other? I told you that only the host will send the packet, right? Just now in the morning. That is not true. Some STP packets will be generated by these bridges. Okay, that's a job of this STP protocol. They talk to each other. Okay, it's like they understand the existence of other bridges in the network, and who is in the loop, who is in the path of forming a loop, and making them keeping making them quiet, so that still the all the hosts, all the LAN segments are connected, and they are still alive, and they are able to communicate with each other. Okay, that is the job of spanning tree protocol. That means what, we are trying to build a spanning tree when there are loops in the circuit, okay, in the network. Now I am going to show you this picture. Okay, uh, this is a little complex. You may wonder, why should I have a LAN of this kind? It is possible. Okay, when you have a big campuses like, our campus is slightly, RVU is slightly not too complex. You can imagine big universities or colleges where many departments are there physically located somewhere else, and few acres of land. Then what happens is they need to be connected together because they are all forming a single LAN, but there will be loops in them, and anybody communicating with any department, there will be a issue. So we have to run a protocol which is a exchange of information among these participants, all the bridges, and that is the traffic which is initiated by these guys. Okay, it is not initiated by the host connected to the network. So whatever I said is, I am just saying that even these routers or switches or the hubs, not hubs, uh, our friend bridges will be sending the packet. What packet? They are going to send a specific configuration packet information. Okay, now I am going to ask you some question on how many bridges are there, are there any loops? Okay, are these are all very standard questions which you can answer. Now which are the bridges forming a loop? Maybe I can tell you. Where is it? This is one loop, and this is one loop. I'm going to draw a nice flower. This is one loop. Okay, what else? I can I draw a different color? Okay, and I cannot do that. No, I can do it. Okay, let me try. Okay, another loop is okay. Anything else? Can I see? I think so. Four loops are there. Okay. So what are they? I have done. Now I am not able to show you the title. What is it? Looping of frames. Now, okay. Now let me give an example. Suppose that a frame enters a bridge B4. Okay, this guy. Okay, from J. Somebody wants to send something. Okay, the host on the LAN segment. Please understand that each of these LAN segments are not existing just because of empty. They are all there, okay, connected to host. Okay, I'm not showing them because we are only interested in the traffic, not interested in the number of hosts or anything. So destination address which is not yet known. Okay, none of this initially when this LAN comes up, none of the bridges are initialized. Now none of the forwarding tables are having any entries. They are all empty. Okay, and they are going to learn. Now before sends set, now what happens, it is going to do a flooding. Remember, if it doesn't know where the target MAC address is, it is going to flood it. It is going to flood it on these two sides. Okay, only this, it will not send it back. Okay, that much knowledge it has. Now what happens, it comes here. Now it is going to flood it because it doesn't know where this particular host is. Now what happens here, now problem is this b6 is receiving from here also, from here also. Now you have formed a loop now. Okay, so this will fellow will send here, and this will go there, and it will go into a loop. and then whatever comes here also will go into any amount of loop unless the host is found and they are learning. Okay, until they learn there will be issue. Okay, I am assuming that we are going to run this protocol. So flooding will happen. Bridge B1 sees a frame. Okay, I am not going to explain this. Very obvious. Okay, let me move this guy now. I don't. Okay, so both directions B1, B4, B6 all will be routed, going around. So why would an extended LAN come to have a loop in it? Okay, I explained it already. Why should there be a loop formed? By intent, if you want to really have a redundant bridges parallelly, you know that it is going to form a loop and you do it intentionally. Okay, one is intentional, other one is unintentional. You just put one switch somewhere between two LANs and then it forms a loop. So it could be intentional or unintentional, but the problem is going to be the same. Okay, you want to have a you don't need to even want to check on whether a loop is formed or not. You want this network to be adaptive enough to learn from changes happening to the network. So you may suddenly decide to bring down one bridge, or you may try to switch off the switch itself. Okay, switch is switched off, or one link is cut, one wire is cut, or you remove one cable. Even then the network should be alive. Okay, so it's not always possible. Sometimes it may be possible that it may be permanently disconnected, but trying to make it alive. Okay, so now B1, B2, B1 to B7 are the bridges, and A to K are LAN segments. Okay, please, I hope the picture is very clear. Okay, when I form a bridge tree, then you may get confused which is what. But right now, you will be clear that each one of them are LAN segments. Okay, and all the bridges are listening. Okay, whatever traffic happening here, both of them are listening, B1 and B5. Similarly, this guy is listening on both the LANs. Okay, so that is what I mean by connected to the LAN segment. Okay, so this is very clear. Now what is that? Bridge and number of ports. How many ports are there is very obvious. I don't think we need to go through a quiz for it. So total number of 20 ports. This it doesn't matter. Just there are how many can bridges have more than two ports? Yes. Okay. Please now going forward, we are assuming that bridges can have more than two ports. Okay. Now, how am I going to form a tree? First of all, we have to form a tree. Then we have to make it spanning tree. Okay. So now my question is: are you going to have like tree we are going to have, right? Are we going to consider only the bridges in our nodes, or are we going to consider the LAN segments also part of that node? Okay, that is the question to be answered. Which is considered to be a node here? Is it only the, in that case I will have 5 nodes or sorry 7 nodes in this, right? Only bridges are there. Do I have to consider the LAN segment also? Now I will tell you the reason. LAN segments can have multiple connections to the bridges. Here you see 2 bridges are connected to this LAN segment, and I can show you somewhere else. Yeah, here also there are 2 bridges are connected. So there may be only one bridge, like K is connected to only one bridge, whereas some LAN segments are connected to multiple bridges. Okay, so as I told you that if you want to avoid the loop, I need to make sure that every connection is considered into a tree. Otherwise, you are not going to form a complete tree. Then, if you do not start with the complete tree first properly, then there is no point in computing a spanning tree. So, we need to consider not only LAN segments, we need to consider both bridges also, LAN segments and bridges as nodes. So how many will be there in this our graph? 18 will be there. 11 LAN segments are there, 7 bridges are there, 18 nodes will be there in our um, tree, complete tree. Okay, we will make it spanning tree later on. Now what is the convention? Let us put a LAN segment will show a square and a circle. Okay, and just so I will put all the LAN segments now. A, B, and more or less positioning them according to the places where they are. Okay, D is here, so I am printing it in alphabetical order. So you can see that they are located more or less close to where they are in the physical picture I have shown you. This actually I have taken it from the reference one book, so you can always get back to that book and you will see more explanation there. Now I have drawn all the land segments, I think, right? J. Okay, J is also done. K is also done. Okay, all of them are done. Now we will insert those bridges in that. Now B1 has come, B2, B3, B4, B5, all of them are coming up. B7. Now how do you connect it? You cannot randomly connect it. You connect it based on the connection what you see here. Okay. If there is a to B3 connection is there, yes, connect it. Now B3 to C is there, yes, connect. What about A to B5? Yes, there is a connection. I am sure you will be tracking me. You have to see left and right. Let me remove all the unnecessary writing. Okay, now B5 to B is there. I am sure you will be able to track it. B to B7 is here. Okay, so I am going in the same way. So I don't need to wait for all the things to be drawn. You can verify it. Let us think our most well connected bridge. This has a five things here, and then we are considering all the land segments of this. Okay, two people are waiting. Who are they? Okay. Okay, so all are in. Okay, so I hope this is clear how we are constructing a tree. Okay, and why should we consider both bridges as well as land segments in our discussion. Okay, now where is my okay, now are there any loops? Yes, cycles are there. Now, okay, what are the conditions to be taken care of while constructing a spanning tree? Now, what are the conditions? You can tell me. Okay, any of the land segments, whatever land segments you see, these are all land segments, right? None of them should be left out. Means I cannot say that I will disconnect this link. Okay, that means I will disable that, invalidate that link. I can't say. Then the J will be left off. Okay, so I don't want any of the land segment to be left out. Remember, they all belong to one single land, so all of them need to be connected to each other. Okay, there may be a need for one of them to communicate with somebody else in the other land, in the physical land, but they are logically they are one single land. So all land segments should be connected to each other. There should not be any loops in the topology. Okay, that is another very good and important condition. That's what we started off with. We don't want the loops in the circuit. Okay, network. So should be spanning tree constructed need to have all the bridges in them. Okay, now my another question is, should the spanning tree constructed need to have all the bridges in them? When I'm saying spanning tree, the final tree which are connected through some bridges. Okay, no segment can be connected without one bridge being there, right? Because bridge is the entity which is allowing you to connect two land segments, right? So they cannot exist without a bridge being somewhere connected. It's like a power line coming. But can I have a bridge which is not in my spanning tree? It is possible. Okay, let us see. Okay, maybe if some of you got the answer, that is good. But because if you are very keen on removing the loop, you should not worry about sacrificing one bridge from the network. Now what I mean by sacrificing, that bridge is not actively involved in transactions, but it is alive, it is sitting there listening to all the traffic and ready to kick in or ready to join the tree if needed. Suppose one of the other bridges or land segments something happens or links break, then this bridges, one of the bridge can come to life and then form a spanning tree. Okay, so we'll see. Now how do we remove the loops? What are the ways you can remove the loops? By disabling the link. Okay, it does not mean that we are removing it again. And then bridges to be configured. Now when you say disabling a link means a link is always connected to two sides of the coin, right? There are some either land segment on one side or two bridges on each side, or it could be anyway any link. If you see, it will be either between two land segment, sorry, it can't be between two land segment. It land segment itself is connected, right? So it will be between a bridge and a land segment, or between two bridges also. Okay, there is a possibility. but I don't see anything directly connecting two bridges. But there is a, you can have it. Okay, you can have bridge to bridge one link you can have. Okay, directly they talk to. In our case, in our picture, it's all connected to some LAN segment always. The bridges are not directly connected. So you have to disable some link, and then bridges to be configured not to send any frames on those link. When I say I am disabling it, I don't want any traffic to be pumped into this particular thing. See, this guy will send it, but anything coming from anywhere, I'm just picking up one LAN, one segment, or one link. It should not send. Okay, you cannot avoid traffic on the LAN side. Please remember. Now, take an example. Suppose you decide not to have this link. Okay, I'm not saying that that is correct or wrong. I'm just for argument's sake, I am taking, considering that one link is considered to be removed. You have picked up that particular link to be invalidated. Then I don't want any traffic on this link, but I can only control this guy not to send anything on this link. But I can't control the hosts which are there in this LAN segment sending something which will be seen on this link. Okay, so remember, so that's why if you see in a packet tracer, there will be a dot somewhere mentioning that it is going to be, that bridge is not going to send any packet on that frames, but there may be some traffic flowing, because if it is connected to a LAN segment, you will see all the traffic within the LAN segment. Okay, that will be there available on that particular link also. Okay, but they are continue to be connected, but they will not be actively participating in the transaction, and bridges will not be sending on that. It's like a no way, no entry for one particular traffic. Okay, okay, fine. Now I am going to construct a spanning tree on this particular tree with a thicker line. Okay, so let me show. Finally, this is one of the spanning tree. I'm not saying that this is the only spanning tree available. Now, are all the LAN segments connected here? Yes. Somehow they should be. Okay. What I mean by all connected, I should be able to go from any LAN segment to any other LAN segment. Some path, some dark line should be there for me to reach through some bridges. Okay. Whether it is roundabout or whether it is shortest path, I don't care. I need to reach. That's it. That is satisfying. Now, can you see something interesting here? How many bridges are not actively participating at all? Okay, that means what, whatever ports it has, whatever links they are connected to, they are not active. So this bridge B3 is like that. This fellow is sitting there but not doing anything. Okay, as good as not present. Similarly, B6 also doing the same thing. Okay, is there anybody else there? No. Okay, now who is the busiest bridge in this? Of course, our friend B1 is the busiest. Okay, because it is connected to everybody and it is active also. All the links are active. Okay, and now anybody, any traffic coming from anywhere can reach anything. Okay, so but the only thing is it may take a longer route, or it may not be the efficient path. Okay, that doesn't matter. Okay, I'll tell you how the spanning tree is formed, then you will know that. Okay, so it's a spanning tree. All line segments are connected and some bridges are inactive. Okay, now how do you show the links which are not actually transferring any active traffic? We show it as a dotted line. So I have put all these dotted lines in this, so that now what do you mean here? This B7 guy is not going to send any traffic on this port. Okay, whereas any traffic on B will be seen on this line. Okay, that's what I am trying to say. It is like this. Okay, no entry on this side, but there may be something coming. B7 will be seeing it. Okay, whatever traffic is happening on the B, remember, by now you should know that they are all LAN segment and they are maybe connected to host. They can initiate traffic. Okay, so they may land here, but this fellow is not going to send, act on anything, because it is supposed to be invalidated link. So it is not going to be actively looking at the traffic there, but it may see it, but it's not going to take any action. I hope so far it is clean. Any chat window, two bridges are inactive, yes, correct. So okay, so I hope so far so good. So let us go forward. Unless you have any, please stop me anytime. Okay, you are free to stop me anytime. Don't think that I need to specifically ask you to talk. You can always talk at any moment. Okay. So what does the bridge B7? Okay, let us read it. What does fully inactive means? Okay. These bridges do not forward any frames at all. What does the bridge B7 do? Where is B7? This fellow. B7 is still connected to all three LAN segments, but it does not send any frames over the port which is connected to LAN B, though it receives the frames going over the LAN B. That's what I told you. Okay, this traffic is there from this side. Nothing is going from this side. Okay, it's a one-way traffic. Okay. Oh, I hope you are clear. It does not process it. Okay, when I say dotted line, no, it doesn't process it. Okay, it sees it, ignores it. Okay, uh, I hope this is clear. See, I am only telling you how spanning tree will look like and what will be the role of these bridges and what is the link being inactive. I am just telling you somehow this spanning tree is formed and this is the reaction. This is the behavior. Okay, loops are removed. So that's all. Okay, how it is formed we are going to see. Okay, if not today, we will do it to on Wednesday. Okay. Now let us see. Each bridge decides the ports over which it is and is not willing to forward freight. So now let me explain now. This decision, is it anybody centrally sitting there and telling, hey bridges, I am the boss of you, you are going to do this? No, it's not that B1 is saying that, hey B3 don't do anything, I am going to take care of all the traffic. No, they actually know it is no bridge is actually a boss here. They become a boss because of their own IDs. ID means the number, okay, bridge ID, and the way they are connected to the network. Initially, what happens is when you set up this LAN connection and all the bridges come to life, what happens is the spanning tree protocol is going to run on each of those bridges. Remember, the traffic is now going to be generated from bridges, not from the host connected to the LAN. So even before you bring up the LAN, hosts are coming up, powering up, and Windows is booting, and Linux is booting there somewhere. Before that, LANs are connected and bridges are alive. Okay, so between who came first, egg or chicken? Here, bridges will be alive before the host become alive. Okay, normally. So before even the host come and then they start talking to each other, the bridges are trying to see which are the links are there which is causing some issue and how to disconnect those links which are forming a loop. Now imagine, how do I find out is there a loop or not? Unless I send some packet. Okay, I mean the bridges send some packet and then see where it all reaches, whether I am getting back from somewhere. So if suppose all the hosts decide not to send anything at all, they are all quiet, then how will the bridges know whether they are forming a loop or not? They cannot wait for the host to send a packet and to realize that they are forming a loop. So how to solve this problem? The bridges are intelligent, I told you initially. They are also going to initiate some traffic into the pump traffic into the network. What traffic is called STP packets? Okay, spanning tree protocol packet. So they are going to send that packet and then sense how is it going into the network. Okay, so that way they try to find out what is the configuration of this whole thing. Individually, they don't know who are all there, but finally they come to know a little bit about the distributed, topology of this particular network. So this algorithm STP is a distributed algorithm. That means it is not running in one place. There is no one boss. Okay, one guy deciding everything. It's all collectively they come to a conclusion that this is how we are going to behave. Okay, it's a you might have heard about no. Mm, what is that? I forget the name of all the. I forget the name. Okay, fine. I will come to that. When they have multiple routers are there and they want to find out what is the way we need to be configured, they run a distributed algorithm and then decide how they are going to be connected to this network. Okay, how they are going to be part of this, what role they are going to play in this network. So who found this excellent protocol? This lady. she's I have tried to send a invite. Actually, she is in, I think she's working in Dell. You can Google for her in LinkedIn. um, I'm not still connected to her, but there is one, she is two level down. Okay, two hops down. There is some, my networking professor, okay, who taught me networking in IIT Madras, is connected to her. Okay, maybe I should get a recommendation through him and then get connected to her. Anyway, she is an American computer programmer, and she is, I think, currently in Dell. She invented this algorithm. Okay, this wonderful algorithm. Okay. Okay, sir, what happens when you add a new bit segment to the topology and the rest of the network is already booted and running? Very good question. When a new bridge is added, okay, somehow that bridge, okay, that particular fellow thinks that he is a root node. Okay, I'll tell about root bridge and all that. So when a new guy adds, they will proclaim that they are the root of this particular network. Okay, particular LAN. That's how they initially claiming to be, I am the boss of this whole network. In our picture here, B1 is the boss. This is a root node. Okay, so when you add a new network, it is going to start off. It is going to boot up. Then it is going to run the STP algorithm for the first time. And whenever the STP algorithm starts first time, that particular bridge will assume that I am the root. Okay, so if you suppose you add a bridge at the end of it, actually I want you to do all this homework of somebody coming in late and then trying to claim that they are the root, and then realizing that there is already one, it's like king is already there and you better be a subordinate, and then they yield to it. Okay, suppose that bridge id of that guy is higher than the bridge ids of this, then they cannot become a root node. Here, the ID number or some other number, which is one of the configuration parameters of those bridges. Individual bridges will have different idea. Okay, they decide who is going to be the boss. Suppose if they have both of them can become a boss, the lower one will become a boss. Okay, something like that. So it will first compete for becoming a root node, and then they realize that they give up and then become a subordinate. Okay, already some root is there. Suppose if the new node which is coming up is the lowest node, then what will happen is the entire network will converge after some time, after they start exchanging information, and finally maybe the new guy who has come into the network can become a root node also. Okay, but it will take some time for the network to converge, and some links becoming it was active will become inactive, some inactive will become active, and new topology will be formed, new spanning tree will be formed, and that becomes a standard for some time. See, always the spanning tree formed is not written on the stone. It is based on the current situation. Okay, which are the bridges are there and which links are active, which bridges are active, and what are their bridge numbers. That is the algorithm decides who is going to be the root node, and the spanning tree protocol chooses that particular guy. Okay, so now let me, how much time we have? Okay, we have 10 minutes. I think 2:10 or what is that? Can somebody tell me how long we have class? What time? Remapping of the topology will take place. Will a lot of time compute power, right? No, no, no. More than the compute power in is running the STP, you are saving a lot of unwanted traffic in the network, and proper routing of frames. So you have to spend some time. That's why when you enable the STP and when you activate those sniffer into this packet tracer, you can see the STP keep coming every 2 seconds. STP packets are coming. So please remember, 2 seconds is a longer time compared to the kind of traffic which is going at a nanosecond range. Okay, so much more traffic is flowing, and STP is like a small peanuts in that whole area. So that is worth spending to make the network effective. Okay, 7 more minutes. Thank you, Aditi. So this problem is addressed by having the bridges run a distributed spanning tree algorithm. That's what I said. Distributed spanning tree algorithm. If you think of extended LAN as being represented by a graph, of course, as shown you, a spanning tree is a subgraph. Okay, entire thing is a graph. Spanning tree is a subgraph with all the vertices and connected and no cycles inside the graph. This is a spanning tree keeps all the vertices of the original graph but throws out some edges. Okay, This is actually, I should say 1D actually, 8.2 1D specification for land bridges is based on this algorithm. Okay, I think D is missing maybe. Okay, that's all in this discussion. Okay.